And basically in section 5.1 and 5.2, you're going to have to be doing some factoring, substitution, combining fractions with unlike denominators, combining fractions with like denominators. You're going to bring a whole bunch of stuff from Algebra 2 back in to this first couple sections. And it is going to be
Waffle
fabulous.
parties?
No. Oh, good. All right. Now, when you solve or when you simplify some of these trig identities, when you simplify, your goal is to get a trig identity or to simplify down to one trig expression. So here, for example, 2, you have two terms. You have a cosine squared x times a cosecant x minus a cosecant x. So you have, those are two different terms. All right, you have one term right here, and you have one term over here, separated by a minus sign. Okay, you count your plus and minus signs, add 1, that's how many terms you have. Now, the first term does have two different functions that are multiplied together. Big whoop. You've seen this before, just not this ugly. So this is kind of like having an x squared y, how about that, x squared y minus a y. Now how would you factor this?
Well, you could subtract the y now.
Take a GCF, right? Take out whatever's in common. So since this is similar, if you take out a GCF here, you would be left with an x squared minus 1. So same concept up here, you're just dealing with bigger functions. We're going to take out a common factor, which would be a cosecant of x. Left over, you have a cosine squared x minus 1. Now, some people are like, okay, then from here, difference of squares. Well, if you do that, don't look for difference of squares first. What should be clicking in your head is, hey, I have a 1 and I have a cosine squared x. I might be able to use my sine squared x plus cosine squared x equals 1 equation. I might be able to use some substitution. But if that's not what popped in your head, Megan, then it's going to need to start.
Okay.
All right? So what we need to do, anytime you see a 1 and a cosine or a 1 and a sine, or a sine and a cosine together, or squares, then you need to start thinking, okay, I got that 1 equation I need to start using. So what we're going to do is we're going to write out sine squared x plus cosine squared x. That equals 1. And this is one of our Pythagorean identities. Now what we're going to try to do is we're going to try to get a cosine squared x minus 1 on one side of your equation. Well, in order to do that, I can just subtract 1 to both sides. And you have a sine squared x plus cosine squared x minus 1 equals 0. Well, how do I get this all by itself then? What do I need to do with my sine squared x? Just subtract it, right? Subtract it to the other side. So if I do that, ooh, that's ugly. Then I just have, then we have a cosine squared x minus 1 equals negative sine of x. So I can take out what's in the blue and plug in a negative sine x. And up here, yep.
So why here to the square?
There should still be a square here, sorry. Thank you. Thank you. There's still a square there. So I'm going to take this out. And I'm going to have a cosecant x. What? Plenty of room. Look, I'm fitting in that same space. So we have this. And what? We do substitution,
This
right?
is the 1 over
So cosecant becomes a 1 over sine, because what we want to do at the very end, we want to get only one of these values. That's what our goal is. So we're trying to get rid of everything else to get it down to having 1. So this becomes a 1 over the sine of x. That's where your cosecant is. And then that's a negative sine squared x over 1.
So it's just sine x.
So you cancel the sine x on the bottom left with one of them on the top right,
And so you just get negative sign.
you just get negative sine of x.
I remember.
And then that is your solution.
I'm just kind of confused why.
Andy?
Yeah.
I can go from cosine squared x minus